today's workshop will be on introduction to Linux. The objective of this particular workshop is if you are logging into a HPC cluster to do your research work and use the compute resources, usually you're typically working with Linux command line more often than not. So this workshop is catered towards new users to get them comfortable with the command line interface and Linux in general, but we'll be mostly dealing with the command line interface. My name is Rakesh Raghavaraju, and as Sridhar had mentioned, I'm a user support analyst. And if you have any questions, please feel free to post it in the chat as we go along. It's a small group, so you are free to unmute yourself and ask any questions as well. A bit about CAC before we begin. Center for Advanced Computing at Queen's University is a center which supports research community by providing access to innovative digital research infrastructure. And we have a high performance compute cluster called FrontNet. And also we have different few other things that we host as well. One of that is highly secure compute network. And also we support several researchers from medical research as well. CAC is part of what we call as digital research infrastructure in Canada. And as a part of Digital Research Alliance of Canada, there are several consortia that enable high performance computing and provide compute resources to our researchers. This includes AceNet, which is on the East Coast to all the way to BCDRI, which is on the West Coast. We cover throughout Canada, and we actually have 5 compute clusters other than FrontNet, and these are accessible to all the researchers at Queen's University and also all the researchers associated with an academic institute in Canada. And we are under digital research infrastructure. We are part of Compute Ontario, and under Compute Ontario, we come under Center for Advanced Computing. Before we begin, I just wanted to, although we will be covering mostly on the command line or on the shell, Linux shell that we'll be dealing with, just to give a quick overview of what an operating system looks like specifically for Linux. So on the like everything in computer science, is divided into layers. On the bottom layer, you have the hardware, physical hardware that we are dealing with, which is your CPUs, your memory in terms of RAM or hard disk that you're dealing with. And at the top layer, you have your user applications, which are graphical user interfaces, your word processors and things like that. And Linux kernel is essentially a go-between between the user space and the hardware, where it communicates. It's a communication layer between the commands that you enter or the things that you want to do on the screen will be sent to the hardware, and the computation is actually done on the hardware, and it spits out the results as you want it. Under graphics user interface, we have something called GNU utilities, and we will be mostly dealing with the shell program over here, which is kind of an interface to the Linux kernel, and it will be interfacing with the hardware kernel, hardware that we are interested in. This is a quick history of how Linux was developed. This is developed by Linux Travaldo in 1991, the Linux kernel itself, and the Linux itself is part of something called Unix-like systems, which was initially developed by Dennis Ritchie and Ken Thompson. These are the same people who developed C programming language. Initially, Unix is a proprietary software, and people in the community wanted to develop a free open source version of it. And there were different research projects, there's different open source projects that were going on, and Linux Travaldo was the one who developed the Linux kernel, but like all the utilities and a few more utilities that we use are part of GNU project, which is developed by Richard Stallman, and they were integrated together into what we know as GNU Linux right now in 1993. And based on that, several distributions have been come out. Before we begin, all the course, all the commands that we'll be following through, I have posted it on a GitHub page. So I'll be posting the link for the GitHub page so that you can follow along more easily in the chat. If you can open this, you will see a GitHub page like this, and all the content is essentially in the README file, but if you need a PDF version of it, like of the slides, I can post it in the GitHub page as well. And also there are some course material that are associated with it. I'll post that in this page as well, and you can download it through this link. So based on the GNU Linux, several distributions are published or catering to different user bases essentially. If you take Debian-based distributions, like probably if you're starting out with Linux, like more often than not, Ubuntu is the most go-to version of Linux for the personal computing. And this has a nice graphical user interface catering towards personal computing users. And other than that, we have Red Hat enterprise-based distributions like Red Hat, CentOS, or Rocky Linux. These are more for servers and things like that, or hosting websites and things like that. Like are mostly running one of these flavors of Linux. And there are several distributions that you can choose from based on your needs. So what a distribution essentially is a Linux kernel associated with GNU tool chain and some pre-packaged, pre-installed software that come along in your user space that are catering to a particular user database. Like if you are going with Ubuntu, more often than not, you will be having a word processor, a spreadsheet application, a browser, and so on and so forth. But if you are going with CentOS with minimum installation, probably you won't find these by default, but you can install these things using package managers. And also, like to compare the in Linux itself, like if you use Ubuntu with graphical user interface, you have a nice graphical user interface as compared to when you are accessing a remote cluster like FrontNet or any of the HPC clusters that we have. So in that, you will be dealing with command line interface. There are certain advantages of using a graphical interfaces, not to take away from that. Like when you're first starting out, similar to Windows, it's more easy to get started with and get familiar with the interface. But in terms of flexibility, it gives you less control in what you can do, and also it's harder to do things repetitively. That's where the command line comes in. One of the advantage of it is it's helpful in creating reproducible and repetitive workflows. And also, if you are connecting to a remote server, these command line interfaces have low overhead, like compared to a graphical user interface where you have to render the graphics on your local computer, which can be quite low and and can be using a lot of bandwidth as well, and that can hinder your user experience per se. So for that reason, most of the HPC clusters that we have or remote servers that we have run a command line interface. That's what the default options that you get are. It's not to say that you can't enable a graphical user interface on a HPC cluster or a frontend, but it's the most easier or in the long term easier way to use a cluster. So our focus will mostly be on the command line and get you familiar with how you navigate in the file system or create your own files, run your small simulations and so on and so forth. That's the main purpose of it, to make you familiar with the command line interface of Linux so that you can establish your workflows and help you with that. If you have a take a look at the Linux file system, it looks, if you're coming from Windows, if you're using Windows for your personal computer, it looks slightly different than that. Like in Windows, you have a C drive where you have your documents and my documents or the desktop directories and so on and so forth. But in a Linux file system, it's slightly different. Like when you log in, you are mostly inside your home directory. That's where you're logged into. Like I'll show this in a short while. And everything is under a root directory called /. Under this, there are several different folders which are catering to different aspects of the Linux operating system. For example, if you take a look at the bin directory, that's where all the applications are. Either it's in bin files or in the user bin directories. Anything that you install by default in your personal computers probably will go to user bin, but all the system utility executables that are related to the system stays in bin directories. In home directory is your user space essentially, and you can copy files, you can create files, delete files, and run your simulations from here. That's what home directories are. On a remote server, things are slightly set up differently, but that's what you'll typically find in your a typical Linux system. This is a quick overview of different file system folders that we have in the file system and what they are for. I will not be going through these individually, but I'll be posting the slides so you can access it later. For the most part, like I said, we will be dealing with the shell to enter our commands and interface with the Linux kernel. This is part of what we call as GNU utilities. And there are several utilities that come pre-built in as a part of GNU Linux. And most of the communication that you do is through a shell command. Shell is nothing but a super program that's an interface between the user, the end user like us, and the operating system through Linux kernel. Even on Microsoft Windows, you have something called PowerShell. That's a shell program as well to interface with the kernel. User can launch or run applications using the shell, and typically you have a terminal or a terminal emulator as a shell program to run your programs. And Bash is the most common shell that you find in most GNU-based distros. With that, let's quickly how do you access a Linux shell from suppose if you're running a Windows machine, for example. For that, you need to connect to a remote server that runs Linux, or you can install Linux through a virtual box on the Windows machine as well. And in the more recent years, like starting with Windows 10, if I'm not wrong, Windows comes with something called Windows Subsystem Linux, which is a terminal emulator, which feels and looks like a Linux command line interface. We can use either of these as an SSH client or a terminal to connect to the remote server, and also run Linux locally on our cluster on top of the Windows machine. Or if you're running Mac, probably you already have a terminal, so there is no need to install another emulator per se, but you can install it within a virtual box. For our purposes, we'll be running most of our commands on the HPC cluster. If you have a Linux machine, feel free to do it on that, but there are some shared files that I have on the system, which will only be accessible on the cluster for now, which I'll be copying it later to the GitHub page. To begin with, like I said, let's go to the GitHub page. If anyone is having any issues, please do post it in the chat. I posted the link for the GitHub page over there. If you open that, you can come to this page. You don't need any GitHub credentials to log in. This is available for public, so you can just click on the link. And these are the things that I'll be covering in short throughout this workshop. Before we do anything, let's get in these in each of these sections. At the end of each of these sessions, I have around 7 exercises to work through the commands that I've presented in the previous sections actually. So all the exercises are listed here or next to this any of the sessions that are provided over here. Let's say we have a couple of commands to copy and download files, and associated exercise file is posted just below that. And everything is available on the GitHub page. You can copy paste it or you can type it in. If you have to be more hands-on on things, and everything is over here. To get started, let's start by connecting to a frontnet cluster. To do that, either, like I mentioned in the previous slide, either you need a mobile external or a terminal. If you are working on Mac, terminal is available by default. You can just click search for terminal on the Mac and you can download it. If not, like you can use mobile external, which I should provide a link. Like if you just Google mobile external, and that will take your download page over there, and you can download one of the free versions over here. Just download the portable version, and if you unzip it, like you can run the MobiX terminal over there. I already have MobiX in my. So once you start MobiX, it will look something like this. Once you start the local terminal, that's an SSH client or a terminal emulator. Which gives you a Linux, which is emulating a Linux shell program. This is a bash shell as well, and we can use this to connect to the server. Command to connect to the server is given over here. So you must have received an email on instructions to activate your page, uh, activate your account. So if you click on that link, and you can enter the username that is given over here. These are your credentials. Essentially, I say this is mine. Like each one of you might have received an email saying that this is your username. And if you log into that, and so once you reset your password, like this is a link to reset your temporary password. Once you reset your password, you will receive another email which lists uh, a link to your password, a temporary password. Once you click on that link, either copy paste it or click on that particular link. And once you click on that link, you will receive uh, a password to your a password to your account. I'll not be showing my password over there, but it's a alphanumeric password, which is about 10 characters, I guess, and we can use that to log in. So in my case, my 244, that's my username, followed by the cluster that I'm accessing in, linux.ca, and when I click enter, prompt me to enter the password. Uh, I'm entering my password right now, but nothing will show on the screen because that's the way the Linux shell is set up. Uh, so once you log in, immediately it'll ask to change your password. For that, like you need to re-enter the password that was the temporary password that you sent that was sent, and any of the new password that you want. So once you change your password, it kicks you out of the login. Again, we have to re-log in to connect to the cluster. Uh, this one might do that. With that, I'm logged in into the cluster and I'm in my home directory. So that's where I am. So to get started, let's take a few minutes for everyone to start logging into the cluster. That will be the initial exercise. So please download and open a terminal or a terminal emulator like MobiXterm and log into the frontend clusters with the instructions given in the previous slide. You see, if you have any questions or queries, or if you are having any trouble logging in, please feel free to post it in the chat, or like you can unmute yourself and ask any questions that you have.
Oh, and Rakesh, I just wanted to ask, do you want everyone to use these ASA accounts? Do you have any files that is
Yeah, like if you want to follow through, like please use this account, like because I have some folders that are created that are only accessible by this account.
Yeah, thanks.
Also, the command to log in is posted in the getting started page section, and you need to replace SA130XXX with the actual username that is provided. The last 3 digits of this username is going to change for each user. And one more thing is the -y flag over here is optional. For this workshop, you don't really need it. But if you want to enable exporting for graphical user interface for your applications, that's something we need to enable using -y. There was a question on if you are using Mac ZSH terminal on Mac, like is there any considerations that need to be aware of using the cluster? For this workshop, once you log into the frontend cluster, the commands will be slightly different on how things work between Bash and ZSH, but like it will be more similar than different. For advanced users, of course, there will be some changes. But once you log into the frontend cluster, you are essentially on a Bash shell by default. And even on Mac terminal, like if you want a Bash shell, I think you can just type Bash, and that will open a Bash shell instead of ZSH, and all the commands are reproducible in that sense. But once you are on the cluster, by default, it's Bash unless you are changing it to a different shell. Hope that answers the question. If everyone is comfortable logging into the cluster, like or if anyone is having an issue, just let me know in the chat. And also, all the course material is in this particular tab file. You can download it, or I will also upload it to the GitHub page. Okay, if no one is having issues, we'll just move forward with the workshop. First thing when you log on to the cluster is this is all you see. And if you are new, like when you're getting started with if you're getting started with the frontend cluster or using the Linux command and you logged in without a graphical user interface, this is all you get. You are in your home directory and you get a Linux command line or a shell interface to interface with the operating system. And there are some basic commands that we'll be going through to essentially navigate through the file system that we have, and also create files in your home directories or any other directories that you have access to. The first set of commands that we'll be dealing with is PWD, which stands for present working directory, which states the folder that you are currently in. Let's do that. If I say PWD, it says that I'm in a folder called global home. That's where all the home directories for the users are on the frontend cluster. And each user has a particular folder called with their username. In this case, my username is SA130244. So I'm landing on this particular folder. If I want to list the folders in this particular directory, I can simply type ls command. And also I wanted to mention that all these are also mentioned in the uh, in the GitHub page that we have. So if you want to follow through, either you can copy paste from here, or like you can just follow through the instructions over there. Just going to put it on a second screen so that I have access to the list of commands that will be running as well. So in this case, my present working directory is my home directory, which is global home SA130.244. Now, I want to move to a different directory. I know that there is a directory called global project workshop intro Linux. Again, that is also provided on the GitHub page. If I wanted to change my directory to this particular folder instead of the current working directory that I'm working on, which is my home directory, I simply type cd, which stands for change directory, followed by the path that I wanted to give. So uh, these folders are in a hierarchical order. So global is the most parent directory under root. Under that, we have a directory called projects. Under that, we have a directory called workshops 2023, because all this course material was created in 2023. So I didn't change the name for that. And under that, for this workshop, we have something called intro Linux. When I type that, and when I type there, so I'm in this particular directory. To confirm it, I'll just type pwd. So now I can see that I'm in the present working directory, which is this. And I can also list the files. I want to know which files and folders are there in this particular directory. And I can use a command called ls. That simply lists all the files that are presently there in this particular folder. Right now, I have a tar file that you can download called course material, and the unzipped version of it, untarred version of it in a folder. And I also have a file called list of commands, which is an empty file, but uh, I have certain files and folders in that particular directory. If I want to move up one directory, there are certain shortcuts that are present. In this ls command, it only lists the files that are not hidden from me. Like if I want to list all the files that are there, I can do something called -a. I can enter -a flag, which lists not just the folders that are visible to the user, but also the folders that are hidden. Uh, in this case, all the hidden folders are starts with a dot at the beginning. There are two special folders called dot and dot dot. What these do is essentially dot refers to the current working directory, and dot dot refers to the parent working directory. So if I want to move one folder up, I can simply do cd dot dot, and that's essentially a link or a shortcut in Windows terms to the parent directory. When I do cd dot dot, you can see that my present working directory changed from workshop intro Linux to just workshop 2023. I can also do uh, dot dot twice, and that goes to parent directories above. If I do that, you can see that I went to global. The current working directory is printed over here. So I went to global from workshop because I moved to parent directories ahead. And sometimes you are entering a particular folder, but you want to go back to the last folder that you are in. So in this case, I'm in workshop.2023 folder, but I don't want to type in the whole thing. There are ways to do that. So if you do cd hyphen, stores the old directory that you have, uh, uh, that you came from. So if I do cd hyphen, it will simply go back to the folder that I was previously at. If I do, and it also nicely prints out which folder I'm entering, because you always don't know where your previous directory is. So it's a nice way to know where you're currently at. And again, if I do ls over here, it lists out all the folders and files that I have in this particular folder. And in Linux, there is a particular special character called tilde. You can find it at the top right left corner of your keyboard on most keyboards below the escape key. Uh, and if you type cd tilde, that takes back you to your home directory. So if I do pwd, so I went to my home directory. This is a shortcut for when you're referring to a home directory. I can also say something like I'm not sure if I have .local. There is no such file, but I can change my directory to that particular folder as well. And I was referring to the different flags that ls command has. In this case, when I type ls, there is essentially no files in my folder, but there are some hidden files in all the user directories. If you want to find those things out, like you can simply type l-a command. So that will list all the files that are there in the current working directory. So I have some bash related files called bash history, which stores all the commands that I entered till date, till today, to a certain limit. Like I think it stores by default previous 1,000 commands. I can just simply do dash bash history to know all the commands that I entered until now. This is in the previous session. Similarly, I can enter, there is also bash rc file. If you want to know the content of the RC file, you can just simply type cat followed by the file name. And once you log into your bash shell, this is the default file that's read. And to initialize anything that you want, like if you want to, we'll talk about environment variables in a short while, but if you want to initialize an environment variable, or once you log in, you want to go to a particular directory instead of your home directory, you can all place a set of commands over here, and those commands will be executed once by default when you log in, and that will take you that folder. Or if you want to create some aliases for some of the commands that can be used, although that's not recommended unless you're a advanced user and you know what you're doing. Those are few tools in your toolkit that you can use to set up your default environment per se. So, and I was talking about one of the flags that list has, that is the -a flag to list all the hidden files and also all the files in your current working directory. But you can have more details about the files as well. What's the ownership of these files? What's the uh, size of these files and things like that? There is another flag called L, and we can use more than one flag together after a hyphen sign. And if I do that, it lists a bunch of things. What these are saying is right now irrelevant, but like it's saying about file permissions, who is owning this file, which group owns this file, and so on and so forth, on which date this file was last changed. It's not really possible for everyone to know all the flags that can be used for each command. The best way to do it is using a man command. Like you can always Google it, but like Linux comes with at least the default utilities that you have, such as list, cd, pwd, and so on and so forth. They have manual pages for each of these commands. You can type man followed by the command name, and that will give you a very thorough description of what that command can do. In this case, if I want to know other options that ls has, I can simply type man followed by ls, and that gives me all the options. We have used A, which stands for all. This gives you all the files that are in the current working directory. And there is also a capital A, which lists all the files, but it doesn't include the current working directory and the parent working directory. And I was talking about -L. So -L is a long list format, which gives you some description about the files that you are listing in that case. And there is another option called recursive. I believe when you type recursive, all the subfolders will be listed as well. Like in Linux, everything is a file, even if it's a file, but it has slightly different permissions associated with it. So if you type ls-r, recursively, all the files in the current working directory and the subdirectories are listed as well. If you want to exit, you can simply type escape and enter column Q. That will fit from the manual pages. Let's start up with one more exercise just to get you started and to get along with the file system. So the exercise is posted in the GitHub page as well. I'll show it out here. In this exercise, open a terminal on your local machine and change the current working directory to your home directory and identify all the files that you have in the folder, including the hidden files. We'll have 10 minutes for this. And once you are done, give me a thumbs up. And also you have an optional exercise where you can go to the man pages or use ls.help, which is a much shorter version of your manual pages. So all the options. Have a look at the manual pages for the list command and explore what you can list in your current home directory and also on the cluster itself. On the cluster, you can go to global project workshop intro Linux. The way you do it is use cd and list all the files over there, or go to intro Linux and just list the files over there. We will take 10 minutes for this exercise and we'll go along with the workshop after that. So if you have any questions, feel free to post it in the chat or you can unmute yourself and ask as well. You're using mobile external, like quickly open a new tab. Now you will be on your local terminal. And if you want to list the files that you have, you can simply type ls, and that will give you all the files and folders in your particular local directory. Similarly, if you want to change directory here, this is the command you use. You can also do while we are doing the exercise, like there are few tips and tricks when you are using a Linux machine, which will be really be handy. So when you're typing a command on Linux, like more often than that, not once you get used to it, like you will do it involuntarily. But if you want to, you can use the tab command to essentially auto-complete your command as well. So if I do cd, and if I want to go to global project and workshop into Linux, I can simply type gl and I can click tab. And if there is no other folder in the parent in the root directory starting with gl, it will auto complete it for me, or it will auto complete it to a particular extent where you can go to a particular folder. In this case, I can simply say go to project, same thing, workshop 2023, and that will auto complete. In workshops, I have several folders with the name intro. So it stops at intro, and if I click files, it says that these are all the available folders. Like, which one do you want to go into? And I can say simply say Linux. That's where I'm at. That's useful as well. And as with anything, you can use the arrow keys to navigate within the command. Like you can either move left or right, something like that. Or you can use top or bottom key, top arrow or bottom arrow, like up arrow or down arrow, to go to the previous command or the next command that you entered. In this case, I can just and hitting up arrow to navigate to the all the previous commands that I entered in the current session. Similarly, down arrow to navigate downward to more recent commands. And if you type in history command, that will list all the files that you entered until now. So essentially, I have all these files, that all these commands that around 40 commands that I entered from the beginning of this workshop, or from the beginning of when I started using this account. You can also use multiple commands in a single line. We'll come through this a little later, but that's something useful that you can use. But a few tricks, like we can just move along with the next topic in this workshop, which is to create files in the folder. So to do that, so next set of commands is to create files or folders in your home directory or anywhere you have permission to. So in this case, we created a folder called Global Project Workshop SA Users. So this is accessible to every user in this group. And if you cd to that, let me cd to that. What is it? Oh, it's SA Users. I have a typo over there. There's a S at the end, like sorry for the typo. And you can go into that folder. Right now, we will be building folders in this particular folder. We'll be building creating files and folders in this subfolder. To begin with, we can create a new folder with our username. In my case, my username is SA130-244. I'm going to do that. So the command that we are going to use is mkdir, which stands for make directory. I paste that. Before I do that, let me see what are the folders that I have. So I have several folders, but I don't have any folder with my username. So what I'm going to do is make directory. Let's say 244. Now it will create a folder called SA244 over here. And you can follow me through this exercise. You can create your own folders in this subfolder. You can create your own subfolders in SA users. And uh, in this case, like you will be the owner of that particular folder. I can view the folder, but I can't necessarily access the content of it. Let's say if I want to access the folder over here, let me see. I think it might have read permissions. So this user has read permission. So everyone, so in Linux, like all the users are part of at least one or multiple groups. In this case, how we set up the accounts is we created a user account for SA130, and all the users under this account, user accounts under these are part of this user group. So when I come to the file permissions, I'll discuss this in detail, but like you can set file permissions to who can access these particular folders. So in this case, if I am part of this group, which I am, I can read the files that are present in it, but I can't modify or write to this particular folder. So if I want to cd to this particular folder, I don't have any problem doing that. So I can copy that, use that. I'll go back to my own folder using cd hyphen. I'm clearing my screen using Control L. And now I can create a new subfolder called, just a moment. I can create a subfolder called example01 in here. I have created a new folder over there, and I can create a new file in this as well. So touch command essentially says that create an empty file in this current working directory. That's what I'm going to do. I am creating a file called file01.txt, and when I click enter, you can see that there is a file called file01. And like I was mentioning before, you can use ampersand command, ampersand to tie up few commands to run in sequence. Let's say I want to create a new folder called example02 and create a file called file02.txt. I can do that using make this file, and so if I type in, I created a new folder called example02, and in that example02, if I list the files, I should see a file called file02.txt. So you can group a set of commands into a single line using the ampersand command. So what will happen is this command will run first, and after it completes, it's going to run the second command. One caveat for this is if any of the previous command fails, that will exit at that moment. So none of the previous next commands will probably run. Oh, if I want to create uh, enter some content into this file, there are different ways of doing it. So there is another command called echo, which essentially prints out anything that you can print out anything that in the codes to the standard output or the screen. In this case, if I say this is Rakesh, and if I click enter, it prints this is Rakesh to the screen because that's where all the output is printed to. But I can redirect this output to a particular file as well. I can do the same thing, saying that this is a first line from echo command. I'll just, and if I use the less than symbol over here, uh, and if I and I can redirect it to file01.txt. Uh, before this, like file01 is an empty file; it has nothing. But once I type this, I can see that file03 will have some content in it. To view the file, you can use a command called cat, which essentially lists all the content in the file. So it simply prints out this is the first line from echo command that's printed to the screen. Instead of it printing it to the screen, nothing is printed to the screen at this moment. It printed the output to the file over here. Update this file with the second line. The way you can do it is you have to do, let me try without, you have to use uh, two greater than symbols, essentially redirecting the output to file01. But when you use a single greater than symbol, what it says is overwrite the file that already exists. If there is some content in that, it will be overridden. So what a double greater than symbol does is like it appends the file. It writes the output to the next line that's available. So if I If I do this, and if I run the cat command again, you can see that this is the first line, this is the third line, say second line. But let's see what happens if I do. You can see that like the previous two lines have been overridden because I just used uh, I streamed using only the single greater than symbol. Uh, these are some ways to output your. This is useful when you want to redirect your output from. In this case, I'm using echo to generate some output and redirecting it to a file called file01. But in practical scenarios, you might be running a simulation and you want to redirect that output to a particular file instead of the screen. Most of the time, you don't have these things are running remotely without any access to the shell as well as any interface at all. So in order to output these output files, you need to redirect it to a particular file where you can read it at a later time. So, and these redirection symbols comes in really handy when you want to check the output once you complete the simulation, like any error outputs, any output that you are interested in. Apart from the echo command, you can also use text editors. The most easier to use one is probably Nano. Once you're getting started, like probably you can get started with Nano. But if you're an advanced user or like if you're comfortable using, you can use Vim or VI or Emacs. Uh, all of them are command line editors. So I can use type in Nano. And if I want to view the file, I can just say file01. This is a line entered on the editor. Good thing about Nano is at the bottom of the page, you have some indications of what commands to use if you want to save, exit, or use any of this. Like if you want to replace a particular string over here, you can use control backslash. And if you want to exit, save and exit, you can just simply use control X. Once I do that, control X, it says that do you want to save the file? I say yes. I type Y, and that saves the file. And if I type control X again, and I click enter, I exited the file. If I do file01, so the new file has been saved. And you can also use VI file01. This editor looks slightly different. Like you have to type in insert command before you enter anything. This is a line from PI. And to save, you have to click escape and type WAQ. That will exit from the editor. I would recommend using Nano if you're getting started. But if you have used VA in the past or Emacs in the past, feel free to use that. Like it's a matter of personal choice, in my opinion. So that's a brief overview of some of the commands that you can use to create new files, examine new files, and also edit these files. Moving forward, we are going to introduce a new set of commands to move, rename, or copy some of these files or delete some of these files. The first file I'll list is in exam. I'll go to example01. I don't have a file here, so I'll create a file called file01.txt. So if I do list command, once I do that, that's to create the file. You can see that there is a file called that. I will enter something into this file. You can enter this line using Echo or Nano editor. And now if I want to copy a version of this file, the command that you use is cp, which stands for copy. If I do copy file, I'm copying it to a file called copy.back, stands for backup. And now if I do it, like I have two files in my folder. One is file, and they're exactly the same. If I copy it, this is the first line. I can remove this file using rm command, but be very careful when you're using rm. Unlike Windows, any file that you deleted is gone forever. We have some backup systems that does snapshots on a regular basis, but I wouldn't rely too much on them for any of the workflow. Only some of the folders are backed up on a regular basis. For example, home and projects are backed up, but not scratch directories when you're using the cluster. So be very careful when you're using the remove command. They can't be undone, especially if you're doing it in your personal computer. Probably there is no backup and they're deleted for good. So when I do that, like I can list the command and you can see that there's only one file in this. And one more thing that I wanted to make a note of is when you're removing a particular file, unlike Windows, it doesn't notify that it's going to permanently delete it. So once you enter the command, it's gone for good. Uh, so again, be careful when you're using this particular files, this particular command, especially remove command for using RM. And RM also has a lot of flags. You can, instead of a single file, you can remove a complete folder. I'll do it in the previous folder over here. Again, you have to be really careful. If I say list example 02, I have a folder called example 02, and within that I have a file called file 02. I can say remove recursively all the R flag stands for like deleting everything recursively, and F stands for delete both files and folders. And if I do that, let me delete the file without these flags and see what happens. It gives me an error saying that this is a directory and I can't delete it. So I need to recursively delete everything within this particular folder. But I just entered remove RF. And when I do that, you can see that everything is gone. So I don't have a folder called example02. And again, with any of the commands, you can use manual command to list all the flags that are available with that particular command. In this case, F stands for force, which means that like all the subfolders will be deleted recursively. And same thing with R. R stands for recursion, and it deletes all the subfolders recursively within that particular folder. And now I want to create if I want to rename the file, for that I have a command called mv, which stands for move. So essentially what this means is I'm moving a file from file 01 to a different file name. So if I do move file 01, renamed, and do that, like, and now I can see that this file has been renamed to something else. I can rename it back to file 01. See that I renamed it back to file 01. And also you can use the same command to move these files elsewhere. So if I want to move file 01 to my parent directory, all I can do is dot dot, which refers to my parent directory, followed by the file name that I want to give. If I say rename, and if I look, like this file doesn't exist in mine, but if I go one folder up, you can see that there's a new file called file rename, and I can just print the command. I don't know if it has anything in it, but I can print out the file that is created, which was part of example 01, but it's moved here. And same thing, you can move this file to a backup directory as well. So if I do that, I have to create a backup directory before I move it there. So like I copy paste, I have to make the backup directory. And if I move, so file 01, which you existed before, is not no more in that particular folder, and it has been moved to backup directory. cd backup, and you can file the file over there. With that, like we'll take another 10 minutes break, and also you can run this exercise on how to create files, and which is listed in the GitHub page over here. Change the directory to intro Linux and create a folder called, sorry, not to intro Linux. I need to change that. Change the directory to, so change the file directory to this particular folder. If you haven't already created a username with your username, create a username with that, and just uh, uh, just run through the exercises that we just did in this particular section, so that you get familiar with how to create files and more comfortable with that. If you have any questions, do post it in the chat, or you can unmute yourself and ask any questions that you have. Okay, let's get started with the next set of uh, uh, commands. Like the next set of commands that we will be discussing is about how to view the files. We can use the text editor like Nano or VI to view the files, but more often than not, like the files are really long, and it's not practical uh, to view all the files that are present using the text editors. So there are a few commands that we can use to essentially start exploring what the content of the file is, and also a few other commands where you can use to search for a particular keyword and like explore the contents of the file. Um, First thing I want you to do is I have listed a bunch of commands that to copy the course material that I have to your own directories. Uh, I have my directory name is SA130244. This will be different, replace with your username. And if you run these particular commands, you will be in a particular folder that looks something like this. And we can do rest of the exercises. If you want to follow along, you can do it along with me. So in this, what I'm essentially doing is I'm changing the directory to SA users, and there is a file called course material.tar file, and copying it to my own directory and untarring it, unzipping it essentially in my changing my directory to that particular file. So the next set of commands that we'll discuss is more. Uh, Unless like these are the two commands that are used to view the content of the file. I have a very, if you go to grep tutorial in this grep tut, if you go to this particular folder in the course material, I have a folder called folder with this particular name. It's a FASTQ file, if I'm not wrong, and it's something related to bioinformatics, and it's a really long file. If I want to know the number of lines in this, I can just simply do that. And I type in. So it contains about 470,000 lines of uh, lines in that particular file. So we can't really explore what the file content is. To do that, there are certain, I'm again typing Control Alt. We can use commands like more and less to explore the content of the file. If I do file extension, you can see what are the files, what are the contents of that particular file. Let me exit it. You can see that it's something related to genomics data, and it has a bunch of different things associated with that. And it's in plain text, so you can actually read what's there in this particular file. You can use enter to go line by line if you're using more command, or you can use space that goes one page at a time. So you can pass through the file quickly and see if there is anything that you want to explore in that. Again, to exit, you just simply type Q, and that will exit from that. Similarly, we also have less, which is very similar command, but what you can achieve by both these commands is slightly different, but more or less both the utilities do the same thing. So again, you can pass through the file. I'm using up and down arrows. I think you can use tab, or again, you can use space to go one page at a time. And if you type Q, you can exit from there. So I will do the same thing with a shorter file. This is much less number of lines than what I've shown previously. It has about 200 lines in it, to not want to be specific, including the headers. If I want to, if I type more, name list, I can pass through the files, like because only some of the contents can be printed, like it's showing some of it. It's with some cities associated with the names, right? And you can use space to pass through it, and so on and so forth. For example, I just want to, instead of looking at the whole file, instead if I want to only look at some of the like what the files look like in the initial few lines or in the final few lines, there is command for that as well. You can use head in this case. If I type head followed by dash n and 10, what I'm essentially telling in this particular line is give me 10 first lines in the particular file. And if I type the following file name, it gives me the first 10 lines. So the first line is a header, which has file name, first name, last name, city, and province. These are made up names from popular characters. And then in some cases, especially when you're looking through log files, you are more interested in the last few lines that are entered. Especially, let's say your history comments are saved in .bash history file. Let's say the history command doesn't exist, and you want to know the last set of files, last set of commands that you used, or you are logging something about your system and you want to know the last few lines so that you know what's you want to explore the log files, then you can use something called a tail command, which essentially prints the last few lines of your code. In this case, if I type m, I name this. So it gives me the last 5 lines that are there in the name list. If you want, and if you go to the end of the page, those are the same 5 lines that we have as we have it here with the tail command. In addition, you can, it's more clear in the presentation over here. So we explored a few commands like more, less, head, and tail to see the contents of the file. And also, sometimes we just don't want to see the content. We actually want to examine the files. Like for that, we have something called grep, which search for a particular keyword in your particular file. In this case, I want to know all the people who are from Toronto. If I want to do that, like if I go to name list here, and if I type Toronto, so it gives me all the people that are based in Toronto. Again, these are made up names. So, uh, so so what this command is doing is it's searching for a key called Toronto in the whole text file line by line. So wherever it matches a particular keyword, like it highlights it in red in this particular case. So you can see that I have grep and there are so many individuals that are based in Toronto. Opposite to this, like if you want to know all the people who are not in Toronto or like who are in some other place, let's say that will list all the people who are not based in Toronto. Like if you can see, if you can explore all the names that are given out here, it will have all the people except for the people in Toronto. Like uh, that's something you can look into and explore. That's a pretty useful command if you're searching for things in your particular file. And you can also use WC. I have used this command previously to know the content of the file in terms of how many lines it has, how many words it has, and so on and so forth. If I type 9 nameless 200, and it says me that it has 201 lines. That's because there are 200 names and one header, so that's 201. And there are 801, 804 words in it, and this is the size of the file that I'm looking at. I have another file called namelist, which I think is about 50. And if I can see that there are 51 files over here and so on and so forth. So I have a bunch of download commands for the next set of tutorials that you have. Oh, okay. Well, before we move ahead, for suppose I don't know if I entered the name with a capital T or a small small letter T. So, but I want to search for all the people who are based in Toronto. The way you can do it is you can use the bracket key over here, listed here. You can say that either it can be Toronto with a capital T or a small t. If I do that again, I don't think I have any. Yeah, there should be no quotes over there. That was my bad. So if I give a capital T or a small t, like it can print out all the files in here. Just to quickly show that's the case, let me change one of the file, one of the name in here to have small t instead of a capital T. So if I do run that again, you can see that this particular name has Toronto with a small t, but it's listed because it takes either a capital T or a small t for this particular character instead of this particular character, and it gives out all the files in there. If I want to know all the people in Toronto and Ottawa, I can just search for two keywords at once. I do this is R symbol over here. On most keyboards, you can find it just above the enter key. And if I type Ottawa, and same thing, all the names. Again, there are no quotes. I'll correct that in the GitHub page. Okay. Sorry, that was a wrong syntax. Like I'll just correct it because it got stuck. Okay. So if you want to search for two keywords, like there is an implicit flag called dash e. If you're searching for a single keyword, you don't need to enter it. But if you want to use multiple search for multiple keywords, you can say grep dash e followed by the keyword that you first keyword that you want to search and the second keyword and so on and so forth. If you look at the man pages again and go to D. So it's essentially looking for patterns that we want to match. In this case, there are something called regex patterns, like it's trying to match that patterns in each single line of the file that you have. That way we can search for multiple keywords in a single file. Just moving on. And also I have some download commands to download a bunch of files from the internet. Uh, so if you run okay, this download file has a bunch of commands that I'm using just to download files from online on GitHub pages. There is a program called NEC 5000. This is related to computational mechanics and wave propagations. And if you look at this file, this file has a bunch of executables inside it. If I do cd, now I have a file called NEC 5000, which is downloaded from here. If I go to this particular folder, and it has a bunch of folders, but what I'm trying to look at is a file name called uh, any executable that starts with the index NEC. I can simply do that by listing all the commands over here. I know that everything will be in the bin directory, so I simply type bin slash one two nine. So that will give me any of the files that have neck followed by a numeric character after it, and it can have any number of characters after that. Like this is essentially to list all the all the bin binary files in that particular folder. You can use these shortcuts or regex examples to uh, find files in this in your particular folders. So these are part of something called as regular expressions, and you can, if you don't know what the exact file name is, you can use these characters to essentially match any of these. Let's say if you put a dot over there, it will try to match a single character, any of the single characters, any of the character by a single character. If you do star like I did in the previous case, like 129 star, I'm saying that match either 1 to 9 for the single character, and followed by that it can have either 0 or more characters after that. That's the reason, like I can print out neck 1 and followed by any characters over here. If you look at it, it will have at least one numeric character after neck, and after that it can have as many characters as I want. Like that's essentially a wildcard character. There are a few other special characters that can be used with regular expressions. Uh, and in this case, I have used a star as well as a bracket. What bracket does essentially is, in the case of Toronto, it either replaces with a T or a capital T or a small t, or in case of 1 to 9, it's essentially replacing it with any of the numeric characters starting from 1 to 9. So a single character excluding 0. So from any, if it has 1 to 9, it will try to match it with that. Using the regular expressions and grep command, you can search for specific characters in your particular file.
Rakesh, sorry to interrupt. Can you copy paste the wget command for NIC
Oh, okay.
5000? Yeah, just in case if you want to practice.
Yeah, oh, yeah, sure. Yeah, I missed that. Everything is in download commands, but like I'll just paste it here. Paste this. I posted the command in the chat to copy the NEC 5000 folder. If not, uh, you can just run copy paste the content of the download command file, and you can just run it as well. And simply do that and just copy until here. Paste it. That'll redo it again. I will give. We can take a few minutes to try out the commands that I entered. And I have an exercise coming up which is relevant for this particular case. And, I'll give a few minutes for that. Okay, we'll move forward with the rest of the workshop. That's a quick overview of how to view the file content, and also to use grep and regular expressions to search for the keywords that you're looking for. Moving forward, like there is also, I have alluded to this particular thing, but like I haven't discussed it in the detail. Like, but there is something called piping, where output of one command can be redirected to to another command. So if you are running a particular program, especially in Linux, you have something called standard output, standard error, and standard input. So each command has a standard output that comes out of it. Like if I say ls, if I say ls like 5,000. So the standard output of this particular command is all the files that are present, all the folders present in this particular thing. So if I want to, I can redirect the standard output from one particular file or one particular command to a different file using the this particular key over here. Again, you can find this above the enter key. So in my case, I want to know number of people that are in Ontario, or uh, and I want to count the number of lines that are there. That's the problem that I want to solve. In this case, all the names are in nameless 200. So if I do char nameless 200, it will list out all the file, all the content of all the lines of the file. So in this case, I only wanted to know how many people uh, are there in Ontario. So I will pipe this output to the grep command. You can directly run the grep command. This is for the demonstration purposes only, where I cat the output to the screen and redirect that output to the grep and only look for anyone with which are part of Ontario in this. If I do that, I'm just copy pasting this. Again, I'm clearing my screen with Control L. So it'll list out all the people that are in Ontario over here. But I want to count the number of people that are there. I can physically count it, but I can more easily, I can use WC to count the number of lines. So again, I can redirect this with WC -L. -L flag stands for number of lines. So when I do that, I can see that there are 89 people that are located in Ontario. And again, I want to know, similarly, you can use the same pip command in a different scenario where you want to know the number of people in Ontario, but not in Toronto. You can do that using the same thing again. Correct. Again, there are no quotes over there that I need to correct. Please. And I'm saying that output the people that are in Ontario, but at the same time, I don't want people who are present in Toronto. So what I do is take out Toronto. If I do that, it'll list all the file, all the people in other cities other than Toronto. And well, you see number of lines. I think it will be 177. That's because somewhere I have a small letter T. If I want to eliminate that, I can use the same thing as I did before. So it'll have all the people in Ontario, but not in Toronto. So the -V flag is a negative, meaning that any lines without this particular keyword. And WC is just word count, or in this case, line count. Uh, that's the quick overview of how to explore the commands, like using grep, more, head, and tail. Uh, there is one more exercise that will take 10 more minutes to go through. So there is a file called download.commands. If you haven't already done that, uh, just do chmod +x. If in that there is a line to download the file that I'm dealing with. Okay, let me find where the file is. one particular file that is missing for this exercise, but let's see if I can find something else. Okay, let me copy. There is a file called new file.fastq over here. This is a fastq file. Copy this to your own directories in uh, user directories and count the number of lines in the particular file. Like I just copy it to my own directory here. Okay. This is in the parent directory of your own user directory. So like copy it from there and count the number of files in that particular file. Optionally, you can also count the sequence that contains ACTG in that particular file. Not every line has it. So count ACT, at least it has ACTG characters at least 10 times in one go. And optionally, you can also download NEC 5000 and untar it. I have done this. Those commands are there in the download command. Like you can run through the first three, and we can take a 5 minutes break. And after 5 minutes, I'll just go through how to. Uh, uh, I'll go through the exercise before we move forward. I've posted the commands to copy the files to your user directories. Replace with your actual username in the command, but like, Okay, we'll just go through the commands. Like I have a file called new file.fastq over here. If I want to look for number of lines on that, we have gone through this command multiple times. You type in wc-l for number of lines, and I type new file, and that gives me how many files are there in this, which is 100. So now if I want to search for a particular key, I can use the grep command, but I want to know any sequence that have ACTG, and at least I have 10 such characters. The way I can do it is, if I type ACTG once, and I can ask you, it says any of the lines that has A or C or T or G, and it prints out all the lines. It even prints out this particular line. So I want 10 in a row. To do that, what I can do is I can type in the same thing 10 times. There are more elegant ways of doing it, but like just for the demonstration purpose, I have done it already, copy pasted it. So like I have ACTG 10 times followed by the new line. And this is the pattern that I am trying to search. Uh, Either it should have either of these characters, ACTG, and it has to occur 10 times. It can be any of that. So if I type that, you can see that anything that has more than 10 characters of this size, like will be printed to the screen. And if I want to count it, I can just simply pipe it to wc-l, and that will give me 25 lines, because only quarter of the file has the genome sequence. So it's printing out the number of lines that it has in this. That's the end of this exercise for searching contents of a particular file. And also there is another command to search for a particular file. In this case, I have several, let's say if I'm looking up for a particular file name. In Windows, probably you can do my home, and you have a search button over here, and you can type whatever you want, and you can search it, and it'll list all the files that matches with that name. You can do the pretty much the same thing on the Linux command line as well. So I'll not go through what module load is. These are pre-installed softwares that are available on the cluster. They are not loaded by default, but you have to load them. If you want a particular software, you need to load them using module load command. In this case, I'm loading a module called Qt, and that will initialize a particular variable called evroot Qt. And I want to search some files in that particular folder. The way I can do it is I can use the find command to search for files within this. I want to match any files that start with Qt. So I can say which folder that I want to search in. There is a variable that stores where these files are installed, that is ebroot qt. And either you can say that, or you can give any other folder path. In this case, the path is stored in this particular environment variable. So I'm copy pasting that, and I'm typing, I want to list all the directories that starts with the name qt. So what I do is type D stands for directory, and any name that matches this particular pattern, please print it out. That's what I'm trying to say. And it lists out all the folders and its full path where they're installed on the cluster. So if I go to any of this, you can see. So that's a particular folder, and it has a bunch of files that are present in that. If I want to move back, I can just simply do a cd hyphen that goes to the previous folder. Similarly, if I want to list all the files and not directories, I can do the same thing with the same command. with a similar command, but instead of type T, I specify it to be a file. And I know that all the names start with small q with for file names, so I just list it out there. And also I can pipe it to WC command to know the number of files that are there, just essentially counting the number of files. If I do that, there are 905 files that starts with the name Qt. And you can search for names like if I want to do cd Qt4, probably there is none. Yeah, if I want to search for Qt core with that particular thing, like it says there are 3 files in these particular folders, and you can go and look for those files that you want. This can come handy when you're looking for library files or header files that you want to link to your program that you're developing. In this case, include has all the header files, and if you're writing a program that includes Qt, and if you want to include these particular folders, that's the path that you have to give in your particular program to find that files. That's the end of the find keyword to search for files in your user directory. So when you log in, there are certain modules. There is a question on module load command. Like this is not particularly pertaining to this particular workshop, but in general, on a HPC cluster, you have a lot of software that are uh, installed, but not all modules are loaded in your environment because there might be software that are conflicting with each other. The way it's managed is through module load command. So what modules does is it sets a particular set of path variables. So by default, if I log out and log in, there are by default a certain modules that are actually loaded, but they might not necessarily be the ones that you want to use. Once I log in, I'll just quickly show. If I say module list, so these are all the modules that are loaded. But in this case, I want to load a module called mix packages. For that, I need to specifically load it. Okay, mix packages. When you do that, any modules that are conflicting usually should be unloaded by default. And if I do module list again, so only Linux package is loaded in here. And you can also load the module Qt. That's the module that you want. And these are the packages that are available for you. And the way it's done is it sets some path variables to load these particular modules in for your particular environment. We'll be going more about this in one more workshop that we have tomorrow on introduction to HPC and bioinformatics. This topic will be covered in a little more detail in that particular workshop. Uh, Moving ahead, like right now, what we are dealing with is the files that we have on our system, except for the Git clone I temporarily did to download the NEC 5000 packages. So if you want to, typically you are working with a particular software or you want to upload your files that you have from your local machine to the cluster, there are certain commands to do that. The first command is wget, which essentially downloads any file from the internet using either HTTP or FTP protocols. Uh, if you go to global project workshop, grep tutorial, if you go to the grep tutorial folder over there, I have a bunch of commands that are listed over here, which we use to download a certain files. So if I list all the files over here, let me use vi. So what wget does is either it uses a FTP protocol to download files from online, or it uses HTTP protocol. Either way, you can download a particular file from it. Initially, I didn't have this file in my folder, but using this particular line, this is the line that we used. So let me go to another directory so that I don't mess around. Um, Sorry, I was in the wrong folder and I didn't have permissions to create files there. If I created a file called test01, and if I do wget this whole command over here, available over here, if I paste, and if I list again, that particular file will be downloaded to this particular folder in this case. The syntax of this command is very simple. Followed by wget, you type in the URL that you're downloading the file from. In this case, I'm using FTP protocol. In some cases, it can be HTTP as well. And more often than not, you'll find HTTP here, and that will download the files to your folder. Typically, all the files are stored in tar format as well. If I and I know that there is a particular folder called NEC 5000. And in the release notes, if you go over here, you will have access to a couple of files that are stored in tar format. And if you want to download these files, you can copy the link, something like that. And again, you can use the wget command followed by the link, which is a HTTP protocol to download that particular file to your to the local to the server that you're working on or the Linux machine that you're working on. You can download it provided that you have the right credentials to access this file. In this case, this is open source software, so it's free to use and free to download. So you can download it, and that downloads it as a tar file. And you want to unzip it or untar it to access the files within that. To do that, you can just simply do tar xvfz and go through what these flags are individually. And once we do that, it will create the folder like 5000, which is part of the package that came as a tar file. If you go to the command that I entered, like there are a bunch of flags that I entered in the tar command. X essentially says that compress it or decompress it, and V says that it's verbose output, saying that whatever it's decompressing, it's printing out to screen saying that I'm decompressing this particular file, and so on and so forth. F essentially indicates that it's a file, and Z is the file format that I'm untarring. If it's a gunzip format, it has usually has an extension called VZ, and I'm untarring that particular format in this case. And same thing with you can download any other files. You can do the same thing with git clone as well. Let me do. Initially, I was mentioning about the remove command. I can use remove rf nic 5000 to delete this file, but be extremely careful when you're using this command because the files are gone for good. Like it's hard to retrieve once they're gone and probably impossible to retrieve in some scenarios. I can also use git clone because there is a git page for this. I'm using git clone to clone this into my directory. Those are certain commands that you can use to clone different directories onto your own system. There is an exercise on how to create files on your local system and upload it to the cluster. Uh, we have about 45 minutes more. So what I'll do is I'll just run the demo of how to do it. And if you have any questions, do let me know in the chats and we can discuss it. So in this particular tutorial, what we are asking you to do is create a file called localfile.txt on the local machine and not on frontnet, and copy to the cluster. You have to do this more often than not when you're getting started, and also when you run your simulation, everything is complete, and you want to copy back your files. In that case, this becomes really handy. In my mobile term, I just opened a terminal and I created a new file called just new file local file.txt, and I am writing some content. This is a local file on, and I'm writing this to local file.txt. Unless there is a local file.txt, oh, there is actually a file already with that name. So what I'll do is I'll quickly override it. Now I want to copy this file to the cluster. The way I'm going to do it is using scp command, which is given here. So in this case, I say scp, which stands for secure copy. And I want to copy, if you're doing a single file, the -r flag is not necessary. But if you are copying a folder to the cluster, like you need a -r flag saying that recursively copy all the files and subfolders in that particular folder. I'm entering -r anyway, it doesn't hurt. And I'm saying that the local file name is local file and not my file. I, I'm copying to uh, my home directory. My username is 132.44 at the late login .cac.cleanstu.ca. And the tilde sign that I mentioned over here stands for user's home directory. You can either explicitly say the complete path to your home directory, something like this. And in some cases, you might not know what the exact path to your home directory is. In that case, you can just use a shorthand, a tilde sign, and that will, once you click enter, hopefully I have entered the right username. And that will upload the file to my home directory. If I go to the cluster, if I do cd, I'm in my home directory again. And you can see that there's a local file that has been uploaded just now. See, it was uploaded at 11:26, and I see the content of the file. I can explore it as well. This is a local file on my laptop that is uploaded. So if you have any files that you want to upload, that's one way of doing it through command line, but there are other ways of doing it as well. When you log into the cluster on MobiXterm, for example, you have a nice FTP interface on the left-hand corner of your MobiXterm terminal. In this case, you can actually upload and download files from here. Right now, if I want to upload some files from my Windows machine, let's say, I can say that readme.txt that I want to upload. I just choose the files that I have in my particular file, and once I do that, I can upload the files to that particular directory. Initially, let's see if it takes a bit of time, but once it's done, it will be uploaded. See, you can see that there is a README file that wasn't there before previously, and you have a nice GUI interface to upload files as well. Oh, uh, uh, there are two different protocols in terms of like what SFTP and SCP does. Like some files that are uploaded in a particular file system that are more secure uses on remote servers typically uses SFTP. But in this case, you can pretty much upload using SCP if you are uploading files from your local system. But any of the SSH terminals that we use this SFTP protocol to upload it. Uh, these are essentially different protocols to upload and download files. But in this scenario, they pretty much are doing the same thing. Hope that answers your question. Okay, this is a short overview of what how you can copy and download files. Other than this, I have shown SCP command to upload and download files, but if you have large number of files and if you want a GUI interface, there are other user interfaces. MovaXM has a nice interface to upload and download files. There is another program called FileZilla that can be used as well. And if you are uploading large databases, like if you have a genomic database that you want to upload, or like a few gigabytes or terabytes of, not terabytes, like few gigabytes of space, or tens of gigabytes, then it's not preferable to use SCP protocol because there is no checkpointing that goes on while you're uploading. If there is any connection error that happens during the uploading process, as these are large files, it immediately exists. In those cases, you can use something called Globus to upload and download files. I will not go through how to set these up. Like these are nice GUI interfaces to set up your endpoints to upload and download files from the cluster and also on your local system. You can set up endpoints to upload files from your local system as well. That's pretty handy in some cases. Um, there are links to our wiki pages, both from our end, like at Frontneck, and also from Alliance, which describes these in much detail. Those are the few references that you want to look into if you, especially when you are dealing with large files. And also when you run your simulation, you want to download that. Probably Globus is handy in that scenarios because essentially you have large file sizes once you complete your simulation and you want to have them stored on somewhere. Uh, this exercise I have already gone through, so I'll skip over this. But like, if you want to try it out, like the exercise is to create a local file .txt and add a few lines to this and upload to your home directory, or you can upload it to some other file path as well. Like I uploaded it to a local directory, a home directory, but if I can upload it to home global project workshop 2023 essay, have access to upload and username. This folder can be accessed by you, so you can upload it to this particular folder as well. That's one exercise you can carry out at a later moment. Okay, moving forward, probably this is the last session before file permissions. So the next topic that I want to discuss is about redirecting input and output from the shell. So like I mentioned, I briefly mentioned this when we used the greater than symbol in the previous case, where you can redirect the output from a particular command to a particular file. The way this is done is through something called standard out and standard errors. Each command comes with a standard out and standard error. Uh, in the next set of tutorials, and we can use greater than symbol to redirect the output from a particular command or a program. If you are running a particular application and that has a particular standard output and this particular standard error, you can redirect that to a file instead of to the screen, which is by default the standard output. Uh, let's quickly go through one more example here. Workshops. That's the path I'm in, and you have to replace this particular line with your own username. And there is a folder called redirecting output. If you go to that particular folder, I have a program that calculates pi. You need not know what that program does, but let's look at uh, that is a simple program to calculate the value of pi approximately. If you have a quick look at that particular program, if you are familiar with C program, you can have print output to either standard errors or standard outputs. That's what I'm doing. If I'm passing one argument to this particular program, it prints something to the standard error. And if it has no arguments, it just prints the value of pi to the standard output. So let's say if I already compiled this program. So if I quickly run calculate pi, so it says that no arguments were entered and the value of pi is 3.1416. That's been printed to the screen. Okay. So if I give one argument, there is no standard, it just simply print out uh, the value of pi. So I'm directing this particular line. If you see, look at the code to standard error and the actual value that I'm interested in to standard output. So instead of printing out to the screen, I want to print out to a particular file. So I can do that similar to the echo command that we did. I can say calculate pi and redirecting this to both output error.txt. If I do that, I'm creating a new file called output error.txt. Let me remove all the files that are with txt again. So the standard error has been printed to the screen, but the standard output has been entered to this. So I want to redirect my standard input and output to different files, out and error. I can do that as well. If if you look at it, like instead of greater than symbol, if you say one, which stands for standard output, and redirect that standard error output to a particular file, and two, which stands for standard error, and you can redirect to a different output as well. In this case, what I can do is calculate pi one out.txt, and I'm redirecting the error to a different file. So nothing is printed to the screen right now. And if I cat out.txt, it says the value of pi is so on and so forth. And if I type error.txt, my standard error has been redirected to this particular file over here. So this comes in. This is really useful, and actually scheduler automatically does it for you. But like when you are running a job on a remote cluster, more often than not, you are running it without any interactive interface, not even the command line. You submit a job, and that job runs remotely on one of the compute nodes. And it just produces the output and exits. So you can use these redirection commands to essentially redirect the output that the simulation is generating to a particular file. If you have, especially if you have some logs that you want to read through, you can redirect it. Slurm, which is our scheduler, automatically does it to two particular files, and there is ways of changing it. But if you are running your particular application and that particular application's output needs to be stored somewhere, you can use these redirection redirect to keywords to essentially store it to a file. And lastly, apart from standard out and standard error, we also have standard input that comes, you can pass through to a command or a line or a program. In this case, we have looked at WC command, which counts the number of lines, and I can redirect instead of in the earlier examples that I showed, you have used the pipe symbol to redirect the output of one command to as the input of the second command. Instead, I can also use the greater than symbol to redirect the output from a particular file. Let's say I have cat.py, which essentially prints all the content of that particular file to WC command. And if I do that, okay, yeah. Sorry. I can redirect. It's not just cat. Like you have to give the file name itself. So this is the standard input that it's reading it from. So like it's just the file name, and it's redirecting the file name, the content of the file to the WC command, and it's outputting the number of lines that it has. It's very much equivalent to this particular line, but just to illustrate what a standard input looks like, this is the way to do it. And that's a quick overview of how do you redirect input or output to a particular file, to a particular command or application that you are running on. Probably one of the most important topics when you are using a shared system like FriendNet is the file permissions. Um, so each user is part of a group or could be part of more than one groups. And who can access these files depends on what file permissions are assigned to each of the folders. In my case, if you look at the essay folder over here, let's look at the file permissions of all this. If you type ls-la long format and all the files that I have, I type capital A because I don't want dot dot. Let's see. So I have a bunch of users using this, and at the very first column that you see, you can see there are a bunch of file permissions that are set. So this is a 10 character keyword, and the first key character in this particular thing notifies whether it's a directory, a link, or a file. In this case, SA130000 is a directory over here. And the next three letters define the file permissions for the user itself. I'm the owner of this, this particular folder is owned by SA130000, and it's owned by the group permissions are set to SU130000, which is all the users in this group are part of this group. So in this case, the owner of this file can read and write this particular file and also execute any executable in this case. Like if you have a program that needs to be executed or for example, I have calculate pi in the previous example, that's an executable. So in order to run that program, we need to have executable permissions. And in order to read the content, like we need R, and W states that you can modify or even delete that particular file. So this particular user, because it's owned by them, like he set his permission, his or her permission to WX, RWX, and for the group, there is a read permission and execute permission. Execute permission for a folder means that you can actually go into the folder and look for it, look for files in that. So if I do cd LA13000, I can go in and I can list the content of the file, but look what happens if I want to create a file over here. It says permission denied because I don't have the permission to make any changes to this particular folder. It simply says that I can't change anything to that. For example, you can do this exercise on your own folder that you own and any of the folders that are owned by any of the other users. Like in this case, there should be one folder that is owned by you and the rest of the folders will be owned by someone else. Like if you try to create, and most of them have read permissions, so you should be able to read the content of that particular file, but you won't be able to make any changes to that particular folder or files through that. Yeah, that's a quick overview of file permissions, and this is really important when you're sharing files with your group members. The way frontend cluster is set up is your PI is the group owner, and under that group membership, like you have different group members. So, and rest of them are others. Like I said, it's a 10-character keyboard. This is these three permissions for the user, and the next three are for the group, and the last three are for everyone else on that particular system who can access it. So you can set permissions based on who can read and write to this particular folder. And if you want to share some files with your group members, you can set read permissions for that. If there are certain members that you want to have write permissions as well, there are additional permissions that you can use with additional granularity. We will not be going into that in this particular case, but that can be done with access control list as well. We have a nice wiki page on that. It's shared in one of the links in the presentation, which I will be uploading as well. And there are ways, these file permissions are not set in stone. You can definitely, the owner of the file can always change the file permissions that are set to it. Let's say there is a command called chmod, which can change the file permission of my make file over here. If I have there is some file called make file in this particular folder, and it has a different set of permissions. If I want to assign my group the file permissions, I can say G plus, which indicates that give write permissions to my group. If I say G minus W, which I'm essentially what I'm saying is take away the permissions from the group to write anything to here. I will quickly demonstrate it here. For example, I have no write permissions in my own folder over here. So anyone who can, if you want to access this file right now, my current folder, like which is LCD SA130244, you can access it, but if you want to create any file here, you can't be able to create it. I'm able to create my own file. Let's say I'm creating my directory SA1300244 again. I can do that, but if any of you try to create a folder in this, you won't be able to do that. I can change that. Like, let me go to some of the users account again, and try to do that. Let me pick one user here. And if I do make directory this, it gives me an error saying that permissions are denied. You will have the same thing when you do it in my folder over here. We are part of the same group, but you can't create the folder files here. Look what happens if I change the permission to I think I have to recursively change it. Again, if you see the file permissions for this particular folder over here, you can see that initially I only had read and execute permissions for a group, but right now I have read permissions as well. If anyone wants to try, you can try to create a folder in this particular folder username, and you should be able to create one. That's a quick overview of file permissions, and also I can change the file permission to a different user. Um, we can change the file permissions to a different user, but I believe we need some admin privileges to make these changes. And my co-instructor shared more information on how to share data with your group members as well. To have handy. So we are pretty much very at the very end of this workshop. There is one exercise that I have where you can try to create a folder called example 01 in this particular folder, and see if you are facing any issues. If you are facing any issues, try to troubleshoot why that's the case. Hence, look into the file permissions and try to understand why you are not able to create the file over there. That's something to try at home, or you can try it. We can take probably 2 to 3 minutes, and if anyone wants to try, they can try it out. Okay, I'll move ahead with the presentation. The last topic I'll be covering is environment variables. Uh, this is particularly useful when you're doing shell scripting, or if you are repeatedly entering on your command line. For example, I have this path called global project workshop that I'm repeatedly trying to get into. So one quick handy way of doing things is you can declare the environment variables in your shell, and you can use them as an alias when you're referring to something. In this case, I can say work directory, and define this as an environment variable. When I do that, when I'm in my home directory, I don't need to type in all the complete path here. I can just simply say work directory, and I'm automatically taken to that. So these are, if you are familiar with any of the programming languages, this is very similar to variables. So you can define variables, strings in this case, and choose them as you go along. In your shell, there are some variables that are predefined. You can know the variables that are predefined using env key, and that will list all the variables that are defined right now in your shell. So because I was loading a particular module, there are some paths that are set around as well. There are certain variables that Linux bash shell uses while finding the executables. Let's say if you want to run GCC or Python for example, how does the shell know where to find the files? Like those are stored in the path variable. If I say echo, what's defined in there? In this case, it's showing the path to different bin directories, which essentially stores the binary files or the executables. And I can find, if I say Python, to run a Python program, let's say, it tries to look for a file called, an executable called Python in one of these files and tries to find it. And that's how it does it. Like if you want to know the exact path, there is a command called which, and that says the exact path to where you can find the Python executable, where it's coming from. And there are some other variables that are used as well, such as LD library paths. Library paths, these are especially useful when you are developing or compiling a new program. So there are certain library files that an executable expects, like particular software expects to compile a particular executable. So in that case, these are the paths where it looks into to find those particular files. Short introduction about introduction to Linux using the command line. This is a quick intro, so like we didn't go into shell scripting and things like that, but more often, like you will be dealing with shell scripting job scripts to run your particular job, but these are the fundamental commands more often that you will use to navigate within the Linux command line or to write your own shell scripts essentially. Um, to give a quick introduction, shell script is nothing but a set of commands that we are entering individually, stored in a particular file, but it offers more flexibility in terms of like we have conditional statements that we can give, we have for loops that you can assign in the shell script and so on and so forth. Like have if you look at the course material, like we have a few examples of shell script on various things such as for loops, how to put commands together and execute it. Like if you are free to copy these files to your home directory or your own local machines and try it out as well. There is an exercise that you can do. Like we'll take 5-10 minutes to do it. Like initially, I was talking about the environment variables that we set while we are loading in our local shell. Uh, on compute cluster, like I previously mentioned, all the modules, there are many softwares that are installed, but not all softwares are loaded on your environment. In order to do that, we use something called module load command. In this case, I want you to load something called DL2, which is a particular software for planet arithmetic, and run each of these commands and see how the env variable, the environment variable, or the path variable changes with each of these commands. And I will give you 5 minutes to do this exercise, and uh, and with that we can end the session. And like, if you have any questions, and we will stay for a few more minutes. So if you have any questions, you can either unmute yourself or post it in the chat. Just I'm trying to look at how the path command looks like in the current environment. It has a bunch of paths that are predefined in this case. I want to post purge, which essentially deletes all the modules that are loaded. And once I do that, you can see uh, fewer paths in the echo path. You can see it's a much shorter list, which are mostly pertain to the local node that we are working on. If I do module, I'm loading these particular software, and if I do echo path, you can see that the path variable got updated based on the modules that I'm loading. And finally, if I do DL2, there are a lot more modules that are available, and you can also see into the path variable to see how it changes with each of these commands. With that, that will be end of today's workshop.